Hey, good afternoon, good morning, good evening, depending on where you are in the world. It's Don Cook, your friendly neighborhood webinar host. We're going to get going here in just a few minutes. I've got 10:57 here local time in Cleveland. Um, Use your Q&A to let me know where you're dialing in from today. I always appreciate seeing those. We had the last couple of weeks, we've been getting a lot of global activity in these webinars. They're really starting to take off, and we appreciate you guys taking time out of your day to come and join these webinars with us. For those of you who this is your first one, we have webinars every week on a different topic, sometimes 2 and 3 webinars. So we love it because we try and give you some great insights without giving you product pitches. So we think we really differentiate there, and we've got a great following. So again, we appreciate all of you coming on. I did see some questions come through, letting me know where people are. Keep those coming through. I got California, another Ohio person. Thanks for joining us. Tennessee, Mexico, excellent. Keep these coming, gang. We love seeing these come through. I got some partners coming through in England. We've got Open Reality there. A great distribution partner there. We've got in the UK there with us. Awesome. Net Peppers in Germany. Thanks for joining us. Excellent. And today with me, I've got Eric Camulli. Eric, say hello. We're not going to get started for a couple of minutes, but we're warming up the crowd a little bit.
Oh, it's fantastic, Don. I am very happy to be here.
You look happy. You look excited.
It is my pleasure to be your esteemed colleague and guest on this webinar today.
I'm lucky to have you today.
Wow, it's really very thoughtful of you, and I'm grateful. I hope that, actually there's no hoping here. I think that I know that we're going to have a great time today.
Absolutely. I've got someone who mentioned they're from Toronto. Welcome. Let's see, we've got Sweden, welcome. We've got Netherlands, our partners from TrueCom are here, great. Thanks for joining us. Florida, welcome. Maine, thanks for coming. All right.
Probably pretty cold up in Maine.
I would think so. I don't know, colder than what we had? I mean, we just got that little Arctic blast here.
Yeah, it was awesome. Went down to about, I don't know, about 8 Fahrenheit.
Yeah, so what's that in Celsius?
Well, what you do, the technique that I learned is you double it and add 30, and it'll get you close. No, that is in Celsius.
That's vice versa. Yeah, the other way.
Versa. Yeah. So if somebody said it was like, if it was like 10 degrees Celsius, you double it and add 30. So that would be 20 plus 30. That's about 50 degrees Fahrenheit. I don't know how to do it in reverse.
Not me either. Our buddy from Toronto says it's negative 16 Celsius there today.
Nice.
Yeah.
Once you get into the negative numbers, it doesn't work.
Yeah, it's cold regardless. It doesn't matter where you are. All right, Eric, I've got 11 o'clock on the nose. Why don't we go ahead and get started?
I think that's a great idea. Thank you, Don.
All right. So I'm going to start off first, just like I always do here, and just walk through a couple 7 signal slides. So for those of you who have not been with us before, what I do is just go through a handful of About Us slides. Again, my name is Don Cook. I'm the Chief Marketing Officer here at 7 Signal. With me today, we are lucky to have Mr. Eric Camulli, our Chief Success Officer.
Do I really look like that?
Well, our website says you look like that.
Okay, just wanted to know.
So today we've got our webinar is Wi-Fi 101. We're going to talk through basic elements. We're going to talk through troubleshooting. We're going to talk about some myths that you may have heard about Wi-Fi. So we're going to set the record straight and tell you everything that you were kind of too afraid to ask about Wi-Fi. You're going to get it all right here. So a little bit about 7 Signal. The company was founded in 2007. We migrated over to the US here in 2011. Major milestone we hit this year, that 1 billion data points analyzed daily. Since we've been at this a long time, we've got a lot of connected devices with our customers, and to be able to crunch 1 billion numbers a day to help our customers analyze, find and fix Wi-Fi issues is a really big deal. We've got over 200 customers around the world and 30 plus partners. 12 patents, 2 of those awarded just this year for our Mobileye product, and we're not going to get into too much product stuff today, but it's good that you know that. We are GDPR compliant, so those of you who are logging in from the EU today can be rest assured that we can support all of your GDPR compliance needs. Our sensors are certified in over 40 countries around the world. That number continues to grow. We're adding Japan. We just added Japan, and we're about to add Russia as well, so we're excited about that.
Wow.
So stay tuned. The company continues to grow, and we're continually excited about it. So I mentioned that our customers come to us to find and fix Wi-Fi issues. We've been at this since 2007, as I mentioned, and over that time, we've created a complete outside-in enterprise framework that's completely AP and device agnostic. So we're here to complement access points and the devices you have on the network. We go beyond what the data that those hardware pieces provide and do it in a completely agnostic way, and here to complement. We believe that our products become part of the network because they are modular based on the discovery process. We'll position the right product with your organization, whether it's something device related or hardware specific. And
yeah, you know, Don, I also really like this outside-in idea, and the reason why is because, you know, Wi-Fi experiences, they take place out on the edge of the network.
that is true.
You know, the infrastructure could be working fine, and so you're not really being helped otherwise. You need to know what's going on out on the edge where the rubber meets the road, where the device meets the air. And so I just wanted to say I really dig that.
No, you're right on. And we have a lot of customers that come to us just for that very reason. So everything's modular, of course, reporting and analytics. And what we're doing is we're looking for the top 7 Wi-Fi problems. Everything, every challenge in the world of Wi-Fi bubbles up to these 7 issues: congestion, coverage, co-channel and radio interference, network services, roaming, adapter and driver combinations, and wireless LAN configurations. Our software dives deep into those problems and helps our engineers find and fix issues related to those. And what we do with our software is we're running active and passive tests on the network itself for packet loss, throughput, jitter, latency, providing a MOS score, looking at those adapter and driver combinations, using our software for a full spectrum and providing packet capture. So all differentiation in the space, and we're the only vendor that provides that functionality through one complete platform. And Eric mentioned that outside-in approach. So it's worth mentioning that, you know, when you're using the legacy approach, which is probably what a lot of you have on this call today, is you're really relying on the access point manufacturer or the device manufacturer to tell you what's going on with the network. And they can give you, you know, top talkers and things like that, but you've got no visibility into the end user experience. So what 7Signal does is we provide that outside-in approach that Eric mentioned before, with our sensors monitoring the air, with our devices giving you what's going on with the end user experience at that device level. So there's no more guessing. It's easier to find and fix Wi-Fi issues. You get right to the root cause. And there's no more, when folks are calling the IT department, there's no more, oh, sorry, I can't see the problem, I can't recreate that issue. We're capturing that information back 90 days. So you're able to go back and find these issues, rediscover these issues, regardless of when they call you at that point, when they're having the issue, or later, or you're finding it proactively without that help desk call. That's where 7Signal comes in. So just from a module perspective, so you understand where we are from a product standpoint. On the left is our Mobileye product. These are our 2 bread and butter products here at 7Signal. Mobileye is the product that runs on the device itself, any Windows, Mac OS, and Android device. It's 100% software based. And Sapphire Eye is our product that we launched initially in 2007. That's come a long way since that time. Continue to update that product. That is our perfect client, our sensor that lives in the up in the ceiling with the access points, or can be plugged into in a wall, or sit on a desk, what have you. That is a hardware and software subscription basis, and that is our spectrum analyzer. So the 2 main differences in the products. Mobileye has that adapter driver combination, really looks at roaming issues, and now, just last week, we added adjacent and co-channel interference to that list. So the product is spectacular in that sense.
I would agree.
Yes,
That's really a big.
Thank you, Eric. Yeah, it was a really big deal.
If you haven't seen that yet, you're going to want to see that. Actually, a device, and from the device's point of view, your laptop computer, and how it can detect that it's experiencing co-channel interference, and how that's actually having a negative impact on the experience.
Mm-hmm.
It's pretty cool.
Very cool. Thank you. Dynamite drop in there. And Sapphire Eye, of course, from a major network point of view, wireless LAN configuration, that's what you'd be using that software for. So let's go to the meat and potatoes of what the folks are here to learn about. Wi-Fi 101.
Outstanding. Thank you, Don. It is my pleasure once again to be here with you and with all of our guests today. And this is Wi-Fi 101. And so as a result, there are folks out there who, hopefully don't snooze off when they hear some things they already know. What I'm hoping is that you hear a few things that then allow you to maybe better understand how you can explain how this Wi-Fi stuff works to maybe some of your colleagues and coworkers who struggle with understanding how Wi-Fi kind of works and why it doesn't work. And then if you're really kind of new to the Wi-Fi space, hopefully, again, you'll pick up on a few cool things. We're going to try to, unlock the mystery for you here. And let me bring up that presentation. And here we go. Okay, so our ace of Wi-Fi here, we're going to unlock the mystery. Here we go. So when it comes to Wi-Fi, guys, I know that we're all familiar with just the complaints. It's, Don, when you have a problem with the Wi-Fi, you just and you're connected to the Wi-Fi, you just blame the Wi-Fi for everything. You don't know, you just say, I can't connect, it's terrible.
The Wi-Fi sucks.
The Wi-Fi sucks. That's actually a common refrain in a lot of organizations. But what we're going to do is we're going to try to break it down for you here. Honestly, it really can just be these 4 problem areas, okay? So it's either your client device, and your client device has a lot to do with your Wi-Fi experience. There are adapters and software drivers that control those adapters inside your device. And that actually has a lot to do with how well or how poor your Wi-Fi experience is. As a matter of fact, a lot of our customers say half their problems or half the complaints trace back to nothing to do with the network, but have to do with client devices and how well or how poorly they actually attach to the network, roam from access point to access point on the network. So that is a biggie right there.
And they never have the data to back it up one way or the other.
Well,
right?
that is a big key, because when you're an IT person and you're trying to explain to somebody it's your device, that sometimes can cause
wants to hear that.
Nobody can cause a little friction, right? Unless you've got some data to kind of prove it, and that's where Mobileye is actually pretty cool. So the next thing is the air. Okay, so the air that you and I breathe is also the medium which that devices are using in order to communicate with access points. So, there could be interference in the air, something going on in the air. You can't see it, but it's there. And again, without that evidence to see what's going on in the air, you don't know that you have a problem. Third, it could be your access points. So your access points get overloaded, they can get congested, or your access points could be fluctuating power. And when they fluctuate power, you could be causing problems with coverage. And also, that could also cause Wi-Fi interference. We'll talk more about that in a little bit. And sometimes, Don, I don't know if you ever experienced this, but sometimes an access point just gets kind of frozen and stuck. It's kind of like a wigged out state, you know what I mean?
But the light's on. Doesn't that mean it works?
The light's on, that is true. But upon further inspection, you'll see no clients are associating to it. And like I said, it's just in kind of like this hung frozen state. That certainly happens. And then finally, it could be something on the back end. So a lot of people don't have good visibility into authentication processes, into IP and DNS services. And that is also something that the solution that 7Signal helps as well. So it's really important to note that it could be any number of those things. Now, let's jump into the meat and potatoes here, as Don said, and talk about licensed versus unlicensed spectrum. Okay, so think of spectrum as these bands of air that are out there. Okay, and some of these bands of air or bands of spectrum you have to pay for in order to use. Okay, and then some are free, meaning anybody can use them. Anybody can use them. So for instance, like 2.5 or 2.6, these are bands that, for instance, like AT&T or Verizon or some other type of carrier might pay for in order to have exclusive rights. Okay, and they pay a lot of money for it. Now, there are some bands of air out there, some spectrum, some highway, if you will, that is free to everybody. And those are what I've indicated right here. Okay, so what we're talking about here is 2.4 and 5 gigahertz, as well as 900 megahertz. And you know, if you're old like me, then you used to have like a cordless phone in your house that used to run on 900 megahertz, right? But now, what's important to note here is that Wi-Fi operates on these two bands of air. Okay, these two bands of spectrum. Now think of these as like highways. Okay, so I've got this one highway that I can drive on, the 2.4 highway, and I've got the 5 gigahertz highway that I can drive on. Now, these different highways, they have, you know, different, you know, just like when we drive to work, there are some highways that have like 5 lanes, and there are other highways that have 10 lanes, 20, you know, 12 lanes, depending upon where you are. And we're going to talk about these. But the most important thing that I want you to know, Don, is that when it comes to these highways, there is a set amount of lanes that are on them. Okay, you can't, you know, you have to operate on the highway. You're not allowed to drive on the shoulder, and you're not allowed to drive on the median. You got to drive on the road. Okay, and the point that I'm trying to get at here is that it's finite space.
Right.
Okay, there are only so many cars that can fit on the highway, and there's just only so many folks that can have a good Wi-Fi experience on these different bands, on these different roads, on these different bands of spectrum, before things start to choke up and things start to really slow down, just like rush hour traffic. Okay. All right, so now the next topic that I want to talk about with you guys is something called propagation. Okay, propagation. So basically, Wi-Fi, it travels over radio. It's radio waves, and it travels at the speed of light. Okay, and so just like you know, when you turn, if you're in a room next door and you close the door, and now there's no more light shining in, right? It's the same thing. There are barriers that prevent Wi-Fi signals from traveling where you want them to travel. And higher frequencies don't travel as far as lower frequencies. So the lower frequency, 2.4, think of it as the red sine wave there. It's like this, you know, it goes really, and it can go really far. And this is why, yeah, it makes
you got
noises.
Those motions for radio. You should be in radio. He's making hand gestures.
I'm making hand gestures that nobody can see, of course, but it's like this big, long sine wave, and those lower frequencies can travel much farther than the higher frequencies, which are like these little milliwaves that have a hard time going further before they just kind of peter out. You know, this is kind of like why you can hear like AM radio stations from the other side of the world late at night. It's because those radio waves are just propagating around the world. It's really wild. Okay, so that's really important to note, that lower frequencies, they can actually travel a little bit further than the higher frequencies. Now, there's more to it than that, okay? There are, just like I said, how, you know, when you close the door, now no more light can get into your room and it's dark. It's the same thing with Wi-Fi. There are certain materials, and when you look at this, chart here, this table, you know, memorize a few things on here, because, for instance, you know, one of the big problems that we see are in buildings that are made out of a lot of concrete.
Hospitals.
Old buildings made out of a lot of concrete. What's going to happen is that the Wi-Fi radio waves are going to be absorbed by the concrete, and it's not going to go through. Okay, so basically, you can have a room with concrete walls. Could be a hotel, could be a hospital, could be anything.
Yep.
You know, you could have an access point, and if there are concrete walls separating two adjacent rooms, it is very likely that one person can have a great Wi-Fi experience, and the person right next door in the room next door could be having no Wi-Fi at all. And then the other one to watch out for is metal. So this could be metal cabinets, metal shelving. We see this in a lot of warehouses. Where there's a lot of metal, and with metal, those radio waves are going to bounce off. They're going to reflect. And that could cause problems as well. You may be expecting the signal to travel from A to Z, but it can never get that far because the signal is bouncing back. It's not propagating as far as you think. So that's really important to know. And now in high dense environments, okay, as you can see, water is a medium barrier to propagation. So when you have like a stadium or a lecture hall that is packed with people, you know, it's like this, you know, you've got all these jelly sacks, you know, we call people that are in the auditorium or the stadium, and the Wi-Fi can have a hard time propagating because of that. So you have to use directional antennas, and you have to have a clever design in order to overcome that. Okay, so this is really important to note. Okay, there are reasons why the signal might not be getting as far as you think. All right, and it's because of barriers to propagation. All right, so now the next thing that we're going to talk about, the next topic, okay, is we're going to talk about how these things are in practice. All right, so we just talked about propagation, and imagine here, this is an office space, and you've got an access point right in the middle of the room, and it has one radio in it dedicated for 5 gigahertz, and another one dedicated to 2.4. Now remember, these are two separate highways. You can't drive on both highways at the same time. You can have people that are operating on one highway or operating on the other highway. Okay, and as you can see here, because of propagation, the blue circle represents 5 gigahertz and about how far it can reach, and the red circle represents 2.4 and how far it can reach. Okay, so you can see that, you know, for instance, this guy right here, he's on the edge, and so his device might be deciding to pick 2.4 or 5, depending upon, you know, what decision his device decides to make. So that's really important right there. Now, if you wanted to have your customers all travel on the 5 gigahertz highway, the way to solve this problem is that you would have to add more access points. And that way, when somebody would walk across the building, they'd be able to roam, hopefully successfully, from one access point to the next to the deck. So it would be these nice handoffs that take place, just like with your cell phone. When you're traveling in your car, your device has the smarts to be able to communicate with the towers and actually hand off from tower to tower to tower. It's the same thing with access points. There's a handshake that takes place where it can actually then roam successfully. Okay. Now, what if you had a situation like this, where all of a sudden a lot of people started gathering on one side of the building in a classroom or a lecture hall or an auditorium? That access point could get overloaded. You like that?
Yeah.
That access point could get overloaded, and people all of a sudden are like, whoa, what's going on with the Wi-Fi? Well, there could be a congestion problem. And when you have a congestion problem, the only thing that you can do, okay, is either, you know, tell people to scatter, and you're not going to do that, or you can add another lane on the highway. Okay, so you can turn on another channel, you can add another access point, is what typically people would do. And in doing so, now I can separate the traffic between channel 36 and channel 149. Basically, it's the same thing as opposed to everybody just driving in one lane on the highway. I'm going to remove the cones, the orange cones, the orange barrels, and now I'm going to open up another lane on the highway, and now the traffic can spread out. Okay. Now I want to illustrate that here as well on my next slide, because this is really, really important stuff. Okay. When you think about the highway, okay, think about a highway as the band, like 2.4 highway and your 5 gigahertz highway. Okay. Now those highways have lanes, and those lanes in Wi-Fi speak we call channels. All right. Now, when it comes to channels and when it comes to lanes, you want to stay in your lane. All right. And when you stay in your lane, you know, things are going to be moving along. But if there are just too many cars and not enough lanes, things are going to slow down, just like rush hour, right? Right. Actually, it was just like yesterday morning when it was snowing and everybody started slowing down, right? And it just and you know, one of the lanes wasn't plowed yet, so nobody was able to use that lane. And so now everybody, all those cars, they were trying to squeeze into just 2 lanes instead of 3, and everything just slowed down.
You need to be able to create an HOV lane just for your device.
Yeah, that would be nice. Now, that's what we have right here, this HOV lane. This is the high occupancy vehicle lane or carpool lane. Now, this is a great example of poor channel utilization. Okay. I don't like seeing this, okay? So this is a perfectly good lane on the highway right here that nobody, Don, is using. All right, this is terrible. And then as a result of this inefficient planning right here, this poor highway planning or poor channel planning when it comes to Wi-Fi, we have a whole channel right here that's not being used. We have all of these cars that are going slower than they should because they can't spread out. And so we have to really understand how to use channels, okay? How to use channels. Let's take a look at that right now. So on this slide right here, this next slide, we are going to actually now talk about the differences between the 2.4 highway and the 5 gigahertz highway. The 2.4 highway, Don, only has 3 lanes, 3 usable lanes, and we call those channel 1, 6, and 11. Now, of course, there's channel 2, 3, 4, and 5, right? Right. But we don't really like to use them. Do you know why?
I do not know why.
Okay, it's because they overlap. They overlap.
Ah.
Overlapping is bad in Wi-Fi. Okay, so you could be on channel 5, you can be on channel 8, but it's bad because it overlaps with 1, 6, and 11. So whenever we're doing channel planning, when it comes to 2.4, we want to stay in our lane and stay in 1, 6, or 11. This is kind of like being on the highway, and have you ever seen it where a car is starting to drift out of his lane and now he's starting to straddle the line on the highway? It's like, whoa, dude, what are you doing?
Right.
And you got to kind of back off a little bit and slow down.
Okay.
It's the same thing in Wi-Fi, okay? When you're in lane, if you're in channel 2 or 3 or 4, you're overlapping with people trying to operate on channel 1. And that's going to cause collisions in the air. It could actually cause collisions on the highway. It's going to cause collisions in the air. And those collisions are going to lead to what we call retransmissions or retries. And when you have a lot of retries, okay, it's kind of like you having to tap your brakes. You're going to slow down.
Right.
And when we see a lot of retransmissions in the environment, we know that we've got some kind of Wi-Fi interference. That's a type of interference where there's overlapping, what we call adjacent channel interference. Okay, so we want to stay in 1, 6, and 11. Everybody stay in their lane. Now, the other thing to note here is that there are only 3 lanes. Okay, and once those 3 lanes fill up,
you're out of luck.
You're out of luck. Everybody's going to slow down to a grinding halt. Okay, there's no you can't drive on the median. You can't drive on the shoulder. You get in trouble. You got to stay in your lane. And so there's just very little capacity when it comes to 2.4. This is why we're trying to move people to 5 gigahertz. It's the big, fast superhighway.
Right.
Okay, now as you can see, when you get onto the 5 gigahertz network, now there's over 20 lanes on the highway. What that means is that everybody should be able to spread out and they should be able to go fast. All right, isn't it great when all of a sudden it's like you're on the highway and then they open up that lane and now it goes from 3 lanes to 4 and everybody can spread out and go fast? Yep. And I know that you want to do that in your new Range Rover. Right. So I mean, this is just really important.
Yeah, and now so from a 2.4 perspective, the reason that those are still around, I assume, is because there's still 2.4 devices out there. Maybe the chipsets are weak, or what have you.
That's right. A lot of devices today. They're what we call dual band, which means that they have one radio inside the device and it can switch back and forth between 2.4 and 5, 2.4 and 5. It's the device that makes a decision. What if you own a device that is just kind of in love with 2.4? Okay, and it just kind of enjoys the company of 2.4. Okay, there's maybe something that you can do in order to influence its decision, and we call that band steering technology.
Okay.
Band steering are some little tricks that you can do in your environment in order to try to influence the behavior of a device so that it will choose 5 gigahertz. Okay.
Okay.
Yeah. So I mean, you can't make the device do anything.
Sure, right.
Okay. But you can try to influence it. Remember, it's the device that decides what it's going to connect to.
Right. And you don't want to turn 2.4 off because that'll cause another issue possibly. Right?
It could possibly. Now, in some situations, you do want to turn 2.4 off, but in other situations, you're right. It's kind of a good lifeline network for people. It does travel to the to the far corners. You know, there are some use cases where maybe you want 2.4, especially in, you know, like a manufacturing environment.
Hospitals.
Yeah, and you know, where the signal needs to travel a little further, but it's tough to manage because there are only 3 channels that you can use, and when you have a ton of devices, then you do run into some problems. Okay, so 5 gigahertz is the place to be for most people, because again, you can spread out and you can go fast, less congestion, just like on the highway. One of the tricks that people do in order to go even faster, Don, is they do something called channel bonding. Channel bonding, okay, where they take 2 of those channels and they bond them together in order to make like a super fast, super wide channel. You can see over there HT40, that stands for high throughput 40 megahertz wide channel.
Okay.
Okay. Now, what do you think VHT stands for?
This is probably very basic, so very high throughput.
You're correct.
Yes.
Very high throughput, 80 megahertz wide channel.
Very technical there.
Yeah. Indeed. Yeah, you got to hand it to them. Now, bonding, creating 40 megahertz wide channels, not a bad idea for most people. Okay, but what you need to know, Don, is that when you bond channels together like that, you are now reducing the overall number of channels that are available to your people. So you got to be careful. For instance, you would never bond channels in a dense environment with tons of people, tons of devices, like a lecture hall or in a stadium or an arena.
Because you want more lanes for them.
You need more lanes.
Yeah.
That's exactly right, Don. You need more lanes on the highway. So you would never, but in an office environment, you know, where there, you know, there's just 20 people working over here and 30 people working over there, not a big deal. I think channel bonding going to HT40 is perfectly fine. And you're literally doubling your ability to go fast. You're literally doubling your ability to go fast. If your computer is capable of going that fast, then you will be able to go that fast. But one thing to note is that if your devices on your network are not capable of taking advantage of those super speeds, then bonding channels, once again, is a fruitless endeavor.
Right.
There's no reason to it. If all of the devices are just old handheld scanners that are only one-stream devices that are only capable of going so fast, then why are you bonding channels? There's no reason for it. Okay, they'll never be able to achieve the super speeds. It's kind of like, you know, it's like I've got a 4-cylinder engine or I've got a V8 engine, you know, in my car. I mean, or I've got a turbo or I don't have a turbo. Now, by the same token, if you go to VHT80, I mean, there's really no reason to be doing that in an enterprise environment. The only place I would recommend you do that is at home. Okay, but even still, you might think that you're going to be able to go super fast if you have an 80 megahertz wide channel at home. But Don, what did we just say? It's not just about, you know, how wide the channel is. It's also about
the device.
It's also about your device.
Yeah, making that decision.
Yeah. Well, not just making that decision, but it's what is your device capable of?
Great point. Yeah.
Does your device have a 4-cylinder engine in it or a V8 turbo? Right. Okay, so if you have a 4-cylinder engine in your device, what's the point of getting on the Autobahn?
Right.
You're not really going to be able to open it up and go, you know, 160 miles per hour. You're just not going to be able to do it.
Right.
Your car isn't capable of really doing that. And so that's another thing to know. All right, now the next thing we're going to talk about, next topic, is noise and interference. Are you ready for this?
I am.
Okay, so remember what I said at the beginning. When it comes to Wi-Fi, it uses the air, and even though we can't see what's going on in the air, there is noise in the air that could be disrupting the Wi-Fi. And so imagine it like this: you're out in the park and you're listening to your radio, and you're enjoying your favorite song, Don. Don, do you have a favorite song or a favorite artist? Or?
I'm a fan of U2, so any U2 song.
Oh, outstanding. Yeah. And I know you're also a fan of podcasts. Maybe you're listening to your favorite podcast.
All right. Yeah.
Okay. Now, what happens when somebody comes along and they start blasting their radio, and somebody else comes along and they start blasting their radio? Okay.
I get out of my car and I start yelling at people.
That's right. That's right. Or maybe you're not trying to have a nice conversation with your friend and you can't even do it anymore because you can't hear.
Right.
Okay. So look at the screen right now. This is actually kind of like what 2.4 looks like when there are so many devices that are trying to talk and other devices that are trying to listen, they can't hear because there is just so much noise in the environment and it's very, very crowded.
Right.
Okay. And remember, there's only 3 lanes on the highway, so those 3 lanes get very noisy very quickly.
And this interference may not include like the microwave interference or the video camera that's in the corner of the room, or other devices themselves.
That's right. So when remember 2.4, it's a free highway. Anybody can use it. So you're right. There's going to be video cameras that are using it. Actually, microwave ovens are known to disrupt the 2.4. Don, I would say the biggest disruptor of 2.4 that we see right now at 7 Signal is Bluetooth.
Oh, okay.
Bluetooth operates on the 2.4 gigahertz spectrum, and Bluetooth headphones, mice, keyboards, speakers, all of this stuff is contributing to noise in the air.
And for our listeners, how are they finding this issue? If this issue exists, they don't know about it, probably, right?
No. You have to have special tools in order to see what's going on. Okay. Now, one of the tendencies that you might have is to just turn up the volume and start shouting. Okay. And now you can hear your favorite song, or now you can hear better, right?
Yep.
But this is now very rude. Okay. And the reason why is because now you're causing problems for your neighbors as well. So you think that, okay, I'm just going to turn up the volume and now I can hear. Okay. I have enough. I'm going to turn it up so I have enough signal to overcome the noise in the environment, and that's what we call signal to noise ratio.
Right.
Okay, enough signal to overcome the noise, but now my signal becomes your noise.
Mm-hmm. So this is common in high density, office buildings downtown, and so you're getting traffic from other floors, your neighbors up top and below. Okay.
Yes, that's exactly right. We call those noisy neighbors.
Of course.
So in Wi-Fi, we say that they're noisy neighbors. I mean, they're not on your network. They're on a different network,
right. Yep.
But they're sharing the same highway.
Right. And so I guess I see this at home when I'm trying to connect a device and I see 10 different my neighbors' wireless access points. Yeah.
That's exactly right. Okay. So even though you're all in different cars, you're all sharing the same road.
Mm-hmm.
Okay. And so you got to learn to play together nicely. So this is an example of not playing nicely.
I see. Okay.
Now, this is what it's like when you move to 5 gigahertz. Okay. Everybody can spread out and it's nice and quiet and you can plenty of signal, very little noise. Okay. And so this is really where you want to be. Now, if you were to compare these 2 spectrum bands, the way that I've just described them, 2.4 would be analogous to going to the sports bar and watching the Cleveland Browns or watching the Cleveland Cavaliers.
The Eagles, for me, Philadelphia Eagles.
Yeah, Philadelphia Eagles you like. Now, when you go into there, you're trying to talk to your buddy. It's loud, it's noisy, people are cheering. Hopefully they're cheering.
If they're at an Eagles or Browns game, you don't know.
Yeah,
they may not be cheering.
They may be yelling.
Yeah.
And not yelling nice things. Okay, but it's hard to hear. Okay, it's hard to hear, and and it's crowded.
Mm-hmm.
Okay, now, if you switch on over to the 5 gigahertz network, this is like you and your lovely wife, Erin, and you guys are able to have a wonderful, intimate conversation. Just kind of look like you, Don.
Yeah, right.
And you guys are able to have this lovely conversation, and you're able to enjoy each other's company, and there's no screaming or yelling. And so that's why, once again, we're trying to use band steering technology in order to get our customers from 2.4 to 5. Okay, now, there's even more to it than that. This drawing right here represents a technology, okay, that most of you out there are probably using, that we call RRM, Radio Resource Management. Now, if you are like a Cisco shop, then it's called RRM. If it's an Aruba shop, they call it ARM, ARM, okay, which is like automatic resource management or something like that. So called different things. But Don, what I want you to learn today is that without you even knowing it, your wireless network is fluctuating power. It's changing channels on different access points. as people move around, and it's doing this automatically in order to try to avoid interference. You like that?
Dynamite animations, buddy.
I appreciate that. I worked really hard on this one. And you know what the problem is that sometimes it does a great job and sometimes it doesn't, and you end up with a situation like this, Don. Do you see something wrong here?
I see some overlapping channels.
Well, actually, it's even worse than that. Okay, when all adjacent access points end up on the same channel, we call that
same channel. I didn't even pick up on
same
that.
channel interference or co-channel interference. Okay, now the reason why this is bad, Don, is because this is analogous to being on the highway, a 3-lane highway, and then they put up the orange cones, and now you're going all the way down into one.
Yep.
Okay, so you're trying to squeeze 3 lanes of traffic down into one. Now, what happens? What kind of experience is that when that happens?
Everything slows down. You got to wait for one car to go through before you can go through.
Oh gosh, it's horrible. Yeah. Exactly. I mean, major congestion. This is a hard problem to catch in an environment, because remember, let's do this again because I'm just so proud of this. This is a hard problem to catch because this is all happening automatically behind the scenes, this fluctuation of power. Okay, and again, it's doing this to try to avoid interference. When it hears like a noisy neighbor, it's going to shrink the cell. Okay, things like that. So, and it's changing channels and such. So what I'm saying is that your network may be prone to these issues unless you're keeping an eye on the situation. And again, you need a system that's going to actually catch or show you when these situations are taking place. So this is a big problem that we see a lot of, okay, out there in the field. Oh, wow, look at this. It is now time to play. It is time to play. Which would you buy, Don? Are you ready?
I'm ready.
Okay, so this is, now we're going to talk about devices a little bit. So this is actually from a website. And when you look at these two devices, Don, side by side, and let's just say that they're both priced the same, which would you buy?
Well, for me, I want the faster processor, right?
That's right.
i5.
That's right. You want the i5 because, everything else looks the same to you. And so if they're both priced the same, then you'd be thinking that you're getting a great deal on a great laptop if you bought the one on the right, correct?
Correct.
Unfortunately, you would be wrong.
Oh, well, this is information I didn't have, Eric.
In the fine print, if you were to read closely, you would have discovered that the laptop that you just purchased is not even capable of getting on the 5 gigahertz network, on the fast highway. You would be relegated to the slow, congested, crowded 2.4.
And I'd blame the Wi-Fi.
And you'd blame the Wi-Fi. Right. Exactly, because you would be driving in a car that was like a beat up old jalopy with a 4-cylinder engine when you thought you were getting the V6 turbo. Okay, now let me explain. Okay, and this is real. I mean, you go to stores. I mean, you can still buy devices today that have these BGN adapters in it. Okay,
they look like a great deal.
And it looked like a great deal. I think it should be a crime, personally. Yeah. They should not be selling these anymore, but they are, and they're doing it to try to offer inexpensive options. But what they're doing is they're setting people up. Like students, they think they're going out and getting a good deal on a laptop, then they bring it to school, and now they can't connect to the real nice, fast network. Okay, so let's talk about these letters here because it is a bit confusing. What I want you to do when you go to the store, I want you to look for the fine print, okay, for the wireless capabilities, and I want you to look, are you ready? For the letter A.
Okay.
Okay, so when you see the letter A, that's your indication that this device is capable of getting on the 5 gigahertz network, which is the faster network that we've been talking about. All right. Now, there's no letter A here. It's just BGN. Now, if this said A BGN, you'd be okay.
Fine. Okay.
If this said AGN, you would be fine. BGN,
no good.
No good. Now, over here on the left, you can see this one says AC. Has a letter A in it.
That's good.
It's good, exactly. So that's the one that you would want to buy. And most devices today are AC, okay? Now, this alphabet soup can be a little bit confusing, all right? Now, I have given you a little way to remember. Just look for the letter A.
Yeah. And this, it's probably important to remember as our customers and prospects are looking for pickers and scanners and you know, other devices.
Yeah, you better make sure that they've that you know your Wi-Fi standards and that you see ABGN or hopefully AGN or hopefully AC. Okay, you do not want devices that are BGN because they would not have the capability to get onto the faster 5 gigahertz network. Okay, so what the Wi-Fi Alliance is doing over here in the lower left is they know that this has been confusing, especially to consumers, and they're actually changing the nomenclature here. So instead of A, C, B, G, and N, it's actually now just going to be Wi-Fi 5 and Wi-Fi 6. Nice and simple, right?
Yep, very.
So AC is Wi-Fi 5, and the new latest and greatest standard is called wireless AX, and that is going to be referred to as Wi-Fi 6. Okay, now a lot of people are asking, well, what is Wi-Fi 6? Should I only be going out and getting Wi-Fi 6 devices or 802.11ax devices? I know Apple just announced that a bunch of their devices now have AX. Also, Samsung has some devices with AX. Well, let's unpack this a little bit for our audience. Wi-Fi 6 or 802.11ax was not really designed for speed. Okay, we pretty much have all of the speed that we need in Wi-Fi 5, which is 802.11ac. It's actually, I mean, that takes us all the way up. I mean, you can go, I mean, to gigabit.
Which your device just can't support anyway.
Which a lot of devices can't even support anyway, exactly. So, I mean, but Wi-Fi 6 has interesting technology in it. And the interesting technology, it's kind of like a channel sharing, okay, through like a multiplexing type of technology, okay? And this is actually something that LTE has been doing for years and years, and now Wi-Fi is finally catching up. So in a sense, with better channel sharing, okay, you can now increase the efficiency of the people who are on the network. Okay, now let me ask you this. If you have AX in your device and I don't have AX in my device, I have an older device, maybe just an AC device, does this channel sharing help?
No, I gotta imagine no.
No, because how can, I mean, you can't share with yourself.
Yeah, I'm not gonna be able to connect.
You can't, you can't share with yourself.
Right.
Okay, so guys, this technology, you know, only works when your devices are mostly AX.
Right, so you got to be aware of your environment.
Exactly, you got to be aware of your devices. So when your device population gets to about 50% AX, now you've got enough clients where those AX clients can start sharing the airtime better. But if you have a couple of clients that are AX and most of your clients are AC, or not,
right,
now you can't really take advantage of the technology yet.
It's kind of like the 2.45 gigahertz thing. You know, there's devices that are 2.4 and won't be able to play in a 5 gigahertz environment.
That's exactly right. Yeah. Okay. So it's the same thing here. So, you know, don't rush out and buy an AX router and think that all of a sudden everything is going to be faster.
Right.
Okay. It doesn't
Good to know.
matter. Yes. Okay. Now you might be, we've been talking about devices here. You know, you want to know what are my device's capabilities. Okay. So this is what I do. What I do is I open up a command prompt on my computer. This is my Windows computer. I open up a terminal window on a Mac, and I'm going to type in this command right here. I'm going to open up a network shell with this netsh command, and I'm going to type in WLAN show interface, and then it's going to print out all these goodies right here. Now, what's most important is I'm looking right here for the kind of adapter that I have in my device. Now, as you can see, I've got this dual band wireless AC 7265. Now, what does dual band mean again?
What does dual band mean again? It means I can either connect to one or the other, 2.4 or 5 gigahertz.
Exactly. It has, and also the AC. What does the A mean?
That means it's good.
That means it's good. You remembered. Okay, it means that it's capable of going onto the 5 gigahertz network, the fast network. Okay, so then what I like to do is I like to then Google my adapter, and when I do, I'm able to get even more information. Okay, I can see that it's a 2x2, a 2-stream device, okay, which allows me to go even faster. It tells me what the capabilities are in terms of going up to, you know, 867 megabits per second. Okay. Now let's talk about this for just a second here. This might sound really awesome. Oh my gosh, I can go 867 megabits per second. That's what my device is capable of. And you might think that if you buy this device, you're going to be able to go that fast.
Right.
Okay. Well, first of all, may I ask, about your internet service provider in your house? Who is your internet service provider?
Charter.
Okay, you use Charter, Spectrum.
Yeah,
so
Spectrum. Yep.
All right. So what do you know what your up and down speeds are from Charter, Spectrum?
600 and something.
Really?
Yeah, it's ridiculous. I thought I needed the high one. Do I not need it?
No, you don't. But okay, that's a different story. Okay, let's.
It only cost me $800 a month.
You're out of your mind. Okay, so here's the thing. I pay for 50 megabits of throughput down, 5 megabits of throughput up. Okay, and I can stream anything that I want to stream. It's plenty fast. Most people have a plan like that. Most people are not like you, Don, and they have just a simple plan. Okay, so if I have just a simple plan where I can upload or download 50 megabits per second, then what good is it to go out and buy a computer that can go 867 megabits per second?
Right. Yeah, you wouldn't need it.
Exactly.
Yep.
The whole point here is maybe you do need it for some other purpose, I don't know. But the point that I'm trying to get at here is that you got to know what your device's capabilities are.
Mm-hmm.
And you got to know what your ISP's capabilities are. And you got to know what your network's capabilities are. And that leads us to this slide right here as we come down the home stretch of our presentation. If you want to have a great Wi-Fi experience, it's a four-legged stool.
Mm-hmm.
You got to know about what your ISP is providing you. You got to know about your environment. You got to know if you've got noisy neighbors, right, Don?
You do?
Yeah, you got to know if you've got noisy neighbors that are causing a lot of noise and interfering with you. Remember, we're all sharing the same highway, okay? And so if you've got some turkey weaving in and out of traffic, that's going to cause problems, right?
No doubt about it.
Okay, so you got to know your environment. You got to know your device. We've spent a lot of time talking about how your devices might not be up to spec. All right, and that's a problem. And then finally, your back-end network. Now, the point here is that you can have the best network in the world, but you can have crummy, slow devices. You can have great devices, but you've got a ton of noise in your environment. Okay, you can have great network, great devices, and no noise, but you've got an ISP that's just choking everything up.
Right.
You've got to really be aware of what it takes in order to have a great Wi-Fi experience. Okay. And there you have it, Don.
Oh, wonderful.
I know. I mean, we could have gone on and on about this stuff for another hour, but you know what? We just wanted to lay out a few simple things for you. Hopefully, you're able to learn a couple of things about how all this stuff works.
No, this was terrific. Thank you very much, Eric. And we're pretty close to on time here. We try and keep it to 45 minutes. We're slightly over. Eric, I've got one slide in that other presentation I want to show during this Q&A session. So for those of you who've got some questions, go ahead and use the question pane that will only send questions to us at 7 Signal, so no one else will see their questions. If you've got an embarrassing one or maybe you missed something, happy to ask those. We won't throw the name out there. So I got a couple questions in here around whether or not we're going to share this recording. We'd be happy to share it with you.
Sure.
Just respond to my email address. I think most of you have gotten this, the updates from me. This is Don. So just reply to any of those emails. I'd be happy to share that with you.
Wait a second. Is this Don?
This is Don.
Okay, good. Just wanted to make sure.
I know why you're saying that. Inside joke. So other than that, there are some other questions in here, and folks have been commenting, especially when we were talking about sports teams. We got some Raptors comments in here and some other ones. But I see a couple questions in here actually around 5G.
Oh boy.
And the difference between Wi-Fi and 5G, who's going to win out, and
sure.
that kind of stuff.
Yeah, see, a lot of people think that there's going to be a winner and a loser, and that's just not the case. Okay, so the whole point of 5G is to actually try to bring Wi-Fi speeds to cellular networks. Okay, Wi-Fi speed, like the ability to go like 100 megabits per second or 150 megabits per second to cellular. All right, so it's going to take a ton. Not only do you have to have a 5G device, just like what we talked about, but you also have to have the infrastructure. And in order to build the infrastructure, okay, I mean, it is going to take a long time. Okay, and it's not that one is going to win out over the other because the carriers are depending upon handoffs between towers and Wi-Fi networks in order to have continuity of experience. If I want to be able to have a 100 megabit per second speed on LTE and then or on 5G, and then I want to be able to hand that off to a 100 megabit per second experience on Wi-Fi. So the two are going to work together. There's no winner or loser. They're going to work together. The cellular companies are going to depend upon the handoffs so that we can transition traffic smoothly, so that we don't run into major capacity issues. Okay. The other thing that I will note is this: is that the infrastructure build out for 5G is going to happen slowly and carefully. They're going to go to the big cities first. And even in those big cities, it's going to be a lot of infrastructure that they have to build out in order to make this happen. So just sit tight. It's not like don't get all caught up in the fever. It really it's a few years away from probably a neighborhood near you.
and there's still going to be interference issues with that, from what I understand too. Similar to what Wi-Fi has with the concrete and the metal and the mirrors. Just like you do with your cell phone.
And actually 5G is going to operate at super duper high frequencies, which means that, remember what we said about super duper high frequencies, they don't travel as far.
They can,
so you have to have really, really small cells. And so, like I said, infrastructure is going to be a big deal.
All right, I'll do one more question here since we're slightly over, but before I get that, what you see on your screen right now, this thank you message, because we don't get into a product discussion on these webinars, if you do want a product tour, we have them every Friday at 12 o'clock Eastern.
Do I get to do those?
You do get to do that. That was a softball for you. Shameless plug, if you will. So go to go.sevensignal.com/tour. Make sure you do put that go in there. If you put in sevensignal.com, it's not going to take you to the right landing page. But we'll send you the invite. Just go ahead and jump in there. It'll be a group demo like this one, or a group discussion like this one, just product specific. So if you're curious about Mobileye or Sapphire Eye, go ahead and jump on that.
Oh, it'll be awesome.
It will be awesome. So one last question here that we've got time for. It says, from your customer experience, what number of SSIDs tend to be too many?
Sure.
And when does it start to get congested?
All right, so here's the thing. I mean, when you have an SSID is basically the name of the network, like the corporate network, the guest network, the voice network, okay? And when you have a ton of these, this is bad, because it all creates more traffic in the air, okay? Because there's beaconing and there's traffic and there's, connect and all that in the air, okay? So what you want to do is you want to cut down on the number of networks that are available. Most organizations are trying to get to 3, okay? A corporate network, a guest network, and one dedicated for voice, because voice is more sensitive. And so they want to have a separate voice network that they can tweak, some of the quality of service, some of the QoS settings on, in order to prioritize packets and such like that. So in terms of what's too many, I would say, 5 or more, in my opinion, is too many. I think that you need to figure out a way to get to 4 or 3. If you have 5, you're kind of teetering on the edge. And again, it's going to be even worse on a 2.4 network, where there's already just not a lot of air and there's so much noise.
Right.
Okay, and that's the reason why we do it. We do it to try to clear up the noise in order to reduce the amount of noise in the air. It's less critical on a 5 gigahertz network because there's just so much room to spread out. Nevertheless, it is good practice to try to reduce the noise, reduce the air pollution by limiting the number of SSIDs or networks that you have. And your target should be 3, although 4 and 5 is certainly acceptable.
All right, thanks, Eric. And with that, we're going to wrap things up for today. Sorry if we keep you a little over today. Try and keep these to around 45 minutes, but great content today from Eric. Thank you very much.
You're welcome. My pleasure.
We'll see you all next week. Thanks for joining us today. Or maybe we'll see you Friday for the product tour. Thanks.